So our next example states that approximately 10% of all people are left-handed. Consider a grouping of 15 people. Let's state the random variable. So my random variable, right, is talking about people that are left-handed. So x is equal, right, left-handed people. All right, so then it says, argue that it is a binomial experiment. So we want to think of our 4 criteria from above, right? So if I scroll really, really fast up, let's just review them really quick, right? So we have, right, fixed number of trials. So fixed number of trials, remember we had 15 people, so there is a fixed number of trials. The trials are independent, which means that what happens on one trial does not influence the outcome of other trials. So if we think of left-handed people, right, if I'm left-handed, it shouldn't affect whether the person sitting next to me is also left-handed or not. So they should be independent. There are only 2 outcomes, right? Yes, they are left-handed. No, they are not. So that would be true. And then the probability of success doesn't change from trial to trial, right? They're consistent. So, 10% would be the probability of each person being left-handed. So let's go back. So it does, right? So sort of our argument is sort of walking through. So yes, all 4 criteria hold to be true. So it is a binomial experiment. So now it says list out N, P, Q, and X. So N is, right, the number of experiments, or in this case, the number of people. So I have 15. P is the probability of success, right, in our case, which we've defined it as 10% or 0.1. Our Q would be 1 minus P, or 1 minus 0.1, which is 0.9. Now X is the possible values, right? The possible number out of my 15. So it actually starts at 0, right? You could take this sample and there's no people that are left-handed, all the way to 15. And so I'm just going, instead of having to write out all 15, I'll just sort of establish a pattern and say to 15. We then want to find the mean. So the mean for a binomial experiment is N times P. So I have 15 times 0.10. Maybe you can see this is 0.15. So my standard deviation is the square root of N times P times Q, which would be 15 times 0.1 times 0.9. So let's go do this in our calculator. So I have seconds, and I have 15 times 0.1 times 0.9. So roughly 1.1619 for the standard deviation. All right, and so my last couple questions ask us about finding the probability. So it says find the probability that none are left-handed. So what it's asking is the probability that x is equal to 0. So just remember, right, x was, sorry, not x. Let me go back. Should have said p. So p, right, or n was 15, p was 0.1, right? That's what we're going to need for our calculator. So I'm going to hit second vars. I'm going to arrow down to binomial PDF. I have 15 trials. My success is 0.1 and x is 0. So I will paste that. And so I get that the probability that are none left-handed, 0.2059, would be my answer for this one. All right, so definitely not unusual. In fact, remember, unusual is 0.05 or less. So what about 7 are left-handed? So the probability that there are 7 left-handed individuals. So we would say, again, second vars. We're going to go down all the way to binomial PDF. A lot of this is going to be the same. So 15 trials, 0.1, and now I want 7. And we'll paste that. So we do want to be careful here. Remember that e to the negative 4 is actually scientific notation. So I'll write this to the side. So 2.77001 times 10 to the negative 4th. What it's saying is we move over the decimal 4 spaces to the left. So we're going to move this over. I'll add some zeros here. Right? 1, 2, 3, 4. So we'd have 0.000 roughly 3, right? That would be the probability of there being a left-handed individual. That one's definitely unusual, right? If we had 7 left-handed people out of my 10. All right, so it says at least 2 are left-handed. So now we have to be careful. We have at least, and then we'll have at most. So at least, right, is saying the probability that x is greater than or equal to 2. Now, I don't have this quite on my calculator, right? I have if it's less than or equal to. So how I calculate at least, it would actually be 1 minus the probability that x is less than or equal to 1. And so what this does is this calculates when x is equal to 1 and x is equal to 2, adds those and subtracts it from 1, and the remaining is everything that's above it. Oops, sorry, I wrote 2, I meant to write 0. That should be 0. Okay, so I'm going to start by typing 1 minus, I hit second, vars, going to arrow down, and now this one we're shooting for binomial CDF. We want the cumulative area. CDF, my trials are 15, my P is 0.1, and then my X value in this case is going to be 1. And hit enter. So the probability, right, that X is greater than or equal to 2, at least 2, would be 0.451 for that there. Right? So probability that at least 2 are left-handed. Now it says at most 3 are left-handed. So at most means less than or equal to. So x is less than or equal to 3. This is, again, a cumulative probability, cumulative area, right? We're finding 3, 2, 1, and 0. And so we can just find this directly from our calculator using the binomial CDF. So second vars, go down to CDF. I have most of this is the same. This will change to 3. Paste that, hit enter. So 0.9444 would be my probability right there. So it's pretty high probability, right? That at most you have at most 3 are left-handed. So my last question for this one states, 7 of the last 15 U.S. presidents were left-handed. Is this unusual? What does that tell you? So we actually calculated this already, right? That was my really, really small one. That was from letter G. So the probability that x is equal to 7, right? 0.0003. Is this unusual, right? Yes, it is unusual. So because it's less than 0.05. So what does this tell you, right? So that tells us, you know, maybe, I don't know, maybe there's a trend with U.S. presidents, more left-handed, or maybe the data has changed, right? So we look at this and, you know, 15 of the last U.S. presidents, right? That's 7, right? That's quite a bit. So we'd want to maybe look at this more. Maybe we could look at all of the U.S. presidents and, you know, see if there's a trend there. Or maybe in general the data has changed. Maybe not 10% anymore left-handed. Maybe it's more than that.